Hi, welcome to my video on extra problem number 3 pertaining to the second derivative of a polynomial. Again, I have a different question, and let's go over this question. I have a graph drawn, and it's f of x, and this is the x-intercept of 3 here, and this is an x-intercept which is 0, and we want to find the inflection point of this graph. So the inflection point is a point somewhere here where it's concave upward here, so that means the second derivative is positive on this side of this inflection point, so some value of x, and the inflection point is the double prime second derivative is negative, it's going downward, so the inflection point is somewhere between 0 and can't say that that's a 2. We can say we know that's a 3, we know that's a 0, and we know that negative 1, 4 lies on this graph. So find the inflection point, which means we have to find the equation. So we have to look at the x-intercepts, and the x-intercepts is also the y-intercepts. So the x-intercepts are 0 and 3, but at 0 there's a parabola here at 0, so that means there's a double, so 0 and 0. So that means that we have a parabola at 0. So we have like 0, 0, we have an x squared. And because this is a 3, then this is an x minus 3 as a factor. So that means the graph of this is a cubic because it has a double root here, or it's a parabola, which is x squared, and there's a single here, so that's a cubic. So it's y equals, we have an a value, and because we have x squared, which is the parabola, times x minus 3. So that's the equation of this cubic, and we know that because I know, hopefully you think about it, it's coming up from the bottom, so that means this a is going to have a negative value. So let's continue. We know that the point negative 1, 4 lies on the graph, and that means that the f, this is the f of x, so I got a y here, so let's put f of x to be, that could be a y, but I got f of x here, let's go with next f of x. So that means the f of negative 1 is equal to 4. So that means that if we put take this equation, the f of negative 1, we put a negative 1 in this equation is a negative 1 squared negative 1 minus 3. So that gives us a, that's a 1, and that's a negative 4. So that gives us negative 4a. So the f of negative 1 is a 4. The f of negative 1 is negative 4a. So that means that negative 4a is equal to 4. Divide by negative 4, and we get a to be negative 1. So the equation, put negative 1 here. So the equation is the f of x is equal to, a is negative 1, so it's negative 1x squared and x minus 3. So, get the inflection point, we have to get the double derivative. So, what is the first derivative? Well, the first derivative, f prime, is, and before I get the first derivative, this is f prime. Let's expand this out so I can do the derivative. So f prime, so that's a negative x cubed plus 3x squared. Now I can do, because I have it expanded out, the derivative is negative 3x squared plus 6x. Negative 3x squared. And the second derivative is negative 3 times 2 is negative 6x. Derivative of 6x is 6. And we'll make our second derivative, or we want the inflection point, our second derivative has to be equal to 0. That means negative 6x plus 6 is equal to 0. Negative 6x equals negative 6. Divide by negative 6, x equals 1. So I have 1. So now that I have the inflection point occurs when the x value is 1. So the f of 1, I'm putting 1 in here, is 1 squared 1 minus 3. So that's 1 squared is 1, so that's negative 1, negative 2, and so that gives us 2. So the inflection point occurs at x is 1 and y is 2. X is 1, y is 2, so the inflection point is right here. Now, you could have taken a guess at that, but really don't know. You could take a guess at this point right here could be 2 and 4. But again, it's a guess. But doing the math on it, it verifies that we have the inflection point at 1, 2. Again, we have, this is an inflection point. Repeat, the inflection point is 1, 2, because on the right side, we have a maximum point. The slope here is positive, and this is a negative. So this means this is concave downward. That means the double prime is negative to the right. And on the left, at left of 1, this is the inflection point. This is positive, is opening upward. So that means a double prime, f double prime is greater than 0. And we can verify that here if you take 1. So if you take a 2 and put in here, you get a negative 12 plus 6, which is negative 6. Or if you put a 3 in here, you get negative 18 plus 6 is negative 12. So any number to the right of 1 will give you a negative double derivative concavity. And any number, if you take 0, negative 1, or negative 2, plug in here, you plug 0 in here, you get a 6. So that's positive. So you can see the concavity is positive, is open upward. Open upward on the right of 1. Sorry, it's open upward on the left of 1, and it's open downward to the right of 1. So there's the inflection point. Just a different question I decided to make up to help you understand. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.